Okay, hi everyone. Welcome back to this video series. Today I want to continue our discussion on Windows Server 2000. So let me just share my screen. Okay, Chapter 12, Performance Monitoring and Tuning. Optimizing your Windows 2000 server for peak performance. Performance monitoring and tuning are essential tasks for system administrators who wish to ensure that their Windows 2000 server environment is running efficiently and delivering optimal performance for both users and applications. Without regular monitoring, servers can become sluggish, overloaded, or even fail to perform as expected under heavy workloads. Windows 2000 Server provides several built-in tools and utilities to monitor system performance, identify potential bottlenecks, and make adjustments to improve the overall responsiveness and stability of the system. In this chapter, we will explore the various performance monitoring tools available in Windows 2000 and discuss the best practices for tuning your server for optimal performance. 12.1 Introduction to Performance Monitoring. Performance monitoring involves tracking the system's health by measuring various metrics such as CPU usage, memory consumption, disk I/O, which is input output, and network activity. By understanding how your system is performing, you can identify potential issues, prevent system failures, and take proactive steps to improve performance. Why performance monitoring is important. Resource management ensures efficient use of system resources like CPU, memory, and disk space. Preventative maintenance helps identify and resolve potential issues before they lead to downtime. System optimization helps in fine-tuning system settings and configurations for improved performance. Troubleshooting aids in diagnosing performance-related problems and pinpointing their root causes. 12.2 Key Performance Metrics. Before we dive into the tools and methods for performance monitoring, it is crucial to understand the key performance metrics that should be monitored in Windows 2000 Server. These metrics are indicators of how well your system is performing and can guide you in identifying areas of concern. 1. CPU usage. CPU usage is one of the most critical metrics as it directly impacts the overall responsiveness of the system. High CPU usage over prolonged periods can indicate that a process or application is consuming too many resources, leading to system slowdowns. High CPU usage could indicate insufficient hardware resources, a malfunctioning or resource-hungry application, excessive background processes. 2. Memory usage. Memory usage shows how much physical RAM is being utilized by the system. Running out of memory can cause the system to slow down or even crash. Virtual memory usage also needs to be monitored, as excessive paging to disk can significantly degrade performance. High memory usage may indicate memory leaks in applications, insufficient RAM for the workload, poorly configured memory settings. 3. Disk usage. Disk input-output reflects how much data is being read from or written to the system's storage devices. Poor disk performance can be a significant bottleneck, especially if the system relies on disk operations for processing of large data transfers. High disk usage could suggest insufficient disk space or fragmented disks, slow or outdated storage hardware, heavy read-write operations from certain applications or users. Network utilization. Network performance is another important metric, especially in environments where servers are heavily reliant on network communication for file sharing, application access, or web services. High network usage might be a sign of bandwidth limitations, high traffic, excessive file transfers, web traffic, network-related issues like packet loss or high latency. 12.3.2 Tools for performance monitoring. Windows 2000 includes a variety of built-in tools that can help you track the performance of your server. These tools allow you to collect real-time performance and data and review historical trends to make informed decisions. 1. Task Manager. Task Manager provides a quick snapshot of system resource usage and running processes. It is a useful tool for quickly checking CPU, memory, and network usage. How to open. Right-click the taskbar, select Task Manager. What it shows: Performance Processes tab displays running processes and their CPU, memory, and disk usage. Performance tab displays real-time CPU usage, memory usage, and system uptime. Networking tab displays network performance statistics. While Task Manager provides basic information, it may not be sufficient for detailed analysis of system performance over time. 2. Performance Monitor. The Performance Monitor is a powerful tool that allows administrators to collect and analyze detailed performance over time. It offers a broad range of counters than Task Manager and supports long-term performance monitoring. How to open. From the Start menu, go to Programs, Administrative Tools, Performance. What it shows: tracks numerous performance counters across different system components, e.g. CPU, memory, disk, network. Can log performance data to a file for analysis over time. Provides visualizations of performance trends, including graphs, histograms, and reports. Common performance counters to monitor: processor time, processor queue length, memory available bytes, pages sec, cache faults sec, physical disks, disk reads sec, disk writes, disk queue length, network interface bytes, total packets. 3. Event Viewer. The Event Viewer logs system events and can provide insight into performance issues related to hardware, applications, or security. It can be used to track system error warnings and informational messages. How to open. From the Start menu, go to Programs, Administrative Tools, Event Viewer. What it shows: system logs displays system-related events, hardware failures, system errors, application logs, logs events generated by applications and services, security logs, security-related events such as login attempts or access to resources. By reviewing Event Viewer logs, administrators can spot warnings or errors that may indicate performance issues. 4. System Monitor. The System Monitor is part of the Performance Monitor tool that allows administrators to monitor various system-level counters in real time. It offers advanced features like charting and alerting. How to open. From the Start menu, go to Programs, Administrative Tools, Performance, System Monitor. What it shows: tracks individual performance metrics in real time, such as CPU utilization, disk activity, and memory usage. Provides historical data and trends to help identify patterns or recurring issues. 5. Task Scheduler. The Task Scheduler can be used to automate performance monitoring tasks, such as running performance reports or triggering alerts based on certain performance thresholds. 12.4. Performance Tuning and Optimization. Once performance monitoring reveals areas where the system may be underperforming, administrators can take steps to optimize the server. Performance tuning can involve adjusting system settings, upgrading hardware, and reconfiguring software. 1. CPU optimization. To optimize CPU usage, consider the following strategies. Increase processor power. If the server is under heavy load, upgrading the CPU or adding additional processors may help. Optimize background processes. Disable unnecessary services or applications that consume CPU cycles. Processor affinity. For multiprocessor systems, configure processor affinity to assign specific processes to specific CPUs to balance the load. 2. memory optimization to optimize memory usage, increase RAM. If the system is consistently paging, add more physical memory may resolve performance issues. Adjust virtual memory, increase the size of the paging file. If the file system relies heavily on virtual memory, monitor memory leaks. Use Performance Monitor to identify processes that consume excessive memory over time, which could indicate memory leaks. 3. Disk performance optimization. Disk performance can be improved by defragmenting disks. Use the built-in disk defragmentation tool to optimize file storage and improve disk access times. Upgrade storage devices. If the disk throughput is a bottleneck, consider upgrading to faster disks, switching to a RAID array, or upgrading SCSI or SATA drives. Monitor disk queue length. A high disk queue length could indicate that the server is waiting too long to access data from the disk. Consider moving frequently accessed files to faster storage. 4. Network optimization. Network performance can be tuned by adjusting network settings. If there are issues with bandwidth or latency, try adjusting TCP/IP settings, enabling jumbo frames, or adjust MTU settings. Optimize network hardware. Use high-speed network interfaces and ensure the network is not overburdened with traffic. Traffic shaping. Prioritize network traffic for critical applications using quality of service QoS settings. 5. Application testing. Applications often consume more system resources than necessary. Here are some running tips. Close unnecessary applications. Disable or remove unnecessary applications that are running in the background and consuming CPU, memory, or disk space. Configure application settings. Many server applications, database servers, web servers allow you to configure their memory and CPU usage settings for optimal performance. 12.5 Best practices for performance monitoring and tuning. 1. Regularly monitor system performance. Consistent monitoring helps identify issues before they become serious problems. 2. Use alerts and thresholds. Set up performance alerts to notify administrators when key metrics, CPU, or memory usage exceed predefined thresholds. 3. Document and review changes. Keep records of any performance tuning adjustments made to the system and regularly review them for continued optimization. 4. Perform capacity planning. Regularly review resource usage trends and plan for capacity upgrades before system performance becomes degraded. 5. Test the benchmark. Before making major changes, test configurations in a non-production environment to evaluate performance impacts. Summary. Performance monitoring and tuning are critical tasks for maintaining the health and efficiency of your Windows 2000 server. By regularly tracking key metrics such as CPU, memory, disks usage, and network optimization, administrators can detect potential issues early and take corrective actions to optimize the system. Using the built-in tools like Performance Monitor, Task Manager, and Event Viewer, you can gather vital data that informs performance tuning decisions. So in the next chapter, we'll explore security best practices for Windows 2000. So I'm going to do it here today for this video. I hope you like listening. Thanks for taking the time, and I hope you have a good day.